today we're going to do lesson 11.8 from geometry. And I'm not going to use the class notes like usual. I'm just going to write with this one because this was an investigation that you were going to do in class with putting together little cubes. It was kind of a cool activity, and of course it's canceled. Before I start the new lesson, proportions with volume, I'm going to talk about proportions with area, which we did back in the area chapter. So back in the area chapter, let me get a pen here. We said if I have a rectangle that is 2 by 4, and if I double each side, so the 2 becomes a 4, and the 4 becomes 2, 4, 6, 8, then their sides, straight lines, are in the ratio of, let's just look here, 2 and 4, 2 over 4, which reduces to 1 over 2. Now, let's figure out the area. The area of this is base times height, so it would be 2 times 4, so that would be 8. And this area is also base times height, so it would be 4 times 8, which is a 32. If I look at the areas and put them in a ratio, 8 over 32, that reduces, I can divide the top by 8 and get a 1, divide the bottom by 8 and get a 4, and that is 2 squared on the bottom, and 1 is 1 squared. So we said, if the sides are in a ratio of m over n, then the areas are in the ratio of m squared over n squared. Okay, so that's the review. We have a conjecture like that already. And now we're going to say, what if we have similar figures again that are in a certain ratio and we look at their volumes? So let's say I have, I'll see if I can draw this here. I'm not a great drawer, as you know. So what if I have a picture that looks like this? And not bad. That this is 2, and this is 4, and it's 1 high. Okay, what if I double all of that? So instead of 2, 4, and 1, I double all of those. So I'll see if I can kind of draw that. Again, bear with me. Not the greatest, you know that. So this has to be 2 high now, so it's a little bit higher. This goes back here. This goes up here. Something like that. Okay, so now this is 2, and this is 8, and this is 4. Okay, if I look at just straight lines, sides, they are in the ratio of, like, if I look at 1 and 2, 1 over 2. Now, I'm going to look at the volume. The volume of this is the area of the base times the height of the object, so 4 times 2 times 1, so that would be 8. The volume of this would be the area of the base, 8 times 4 times the height of the object, which would be 2, so that is 64. So the volumes are in the ratio of 8 over 64. Okay, now I can reduce that, divide the top and bottom by 8. 8 goes into 8 once, 8 goes into 64 8 times. And now if I write those with powers like I did for the areas, 8 is 2 to the third, and 1 is 1 to the third. So back here, if the sides are in the ratio m over n, the areas are in the ratio of m squared over n squared. Our new conjecture, if the sides of two similar figures are in the ratio of m over n, then their volumes are in the ratio of m cubed over n cubed. So that's the new conjecture. I'm trying to figure out what number it is. I should have looked at this before. It's the next one on your list. 96. Conjecture 96. Okay, now here's an example. Two square pyramids are similar. Okay, so they have a square for the bottom, and then they all come up. They're pyramids that comes up to a peak on the top. Not a great drawing, as usual. The corresponding sides are in the ratio of 3 to 4. So this is 3, and then this one would be a bit bigger. Probably too big, but that's okay. They all come up to 1 point on the top. So the sides are in the ratio of 3 to 4. Now, that doesn't necessarily mean that they are 3 and 4. You know, this could be, if I multiply by 2, this would be 6 and 8. 6 and 8, when I reduce them, are 3 over 4, you know, so it doesn't matter. But they're in the ratio of 3 to 4. Okay, the smaller pyramid has a surface area, which is 46 square inches. And they want me to find the surface area of the larger one. Then they're going to give me a problem with these same pictures with the volume, but I'll do the surface area first. So if the sides are in the ratio of m over n, then their areas are in the ratio of m squared over n squared. So that means I take 3/4 and I square the top and the bottom. So the area is 3 squared, 9, 4 squared is 16. So the areas are in the ratio of 9 over 16. So now I'm going to say 9 over 16 with the top one being the smaller and the bottom one being the larger. The surface area of the smaller one is 46. And the surface area of the larger one, I do not know. So when I cross multiply, I get, I stopped there because I went to get my calculator, but I'm back. So now I have 9 times the surface area is equal to 736. So when I take 736 now and divide it by 9, the surface area is 81.7 repeating, so 81.8, let's say. And this was in square inches. So that would be the surface area of the larger of the two figures. Okay, then I'm going to erase this. No, I'll just leave it. Okay, so we'll do the same thing. I have this square pyramid, and the ratio from that one to a larger one is sides are 3 to 4. So that's m over n. And now they're going to ask me something about the volume. It says the smaller pyramid has a volume of 54 cubic inches, and they want me to find out the volume of the larger one. So if the sides are in the ratio of 3 to 4, the volumes are in the ratio of m cubed over n cubed. So that's 3 cubed over 4 cubed. And that turns out to be 27 over 64. So that's the ratio I'm going to use. 27 over 64 for the volumes. Okay, the smaller one is 54. My smaller one is going on the top here. And on the bottom is the volume that I have to find. So when I cross multiply, I get 24V equal, oops, I messed up, didn't I? So, let's go back. This is a 27. Okay, instead of redoing the whole video, I'm just going to say I made a mistake. So there's my 27. So 27V equals, and when I multiply on this diagonal, they turn out to be 3,456. If I divide by 27, then my volume ends up being 128, and this is in inches, and it's volume, so it's cubic inches. So even though it wasn't a fancy PowerPoint with pictures, I hope that this actually taught you how to do these problems, and reviewed also how to do the area problems with similar figures also. Bye.